Welcome to a lesson with Dr. Powell. Let's take a look at how we can use our current ideas of derivatives, including the power rule, where n can be anything except 0, that is, and we get n x to the n minus 1. Now, I want to emphasize the point that we don't want to have 0 here, because if we did that, we would end up getting 0 times x to the negative 1. And this right here, wouldn't really, it doesn't really quite equate, especially since this is a constant. And this over here actually has a hole. So the derivative of constant should be a constant 0, not something with a hole, right? Because you can't plug in 0 into that. So really, this rule really only works, I guess, if n is not 0, but it works for any other n. All right. So let's look at cases when we might want to use this. All right. So for instance, what if we have something like x to the 1/2 minus x to the 3rd, and maybe this is all divided by x to the 1/4. I want to take a derivative of that. Well, let's simplify this and rewrite it so it's the sum or the difference of two things where we can apply the power rule. We can unadd fractions, because this is a common denominator, just kind of split it into two parts here. X to the 1/2 minus x cubed over x to the 1/4. Then realize this is the same base, and these exponents right here will subtract. So 1/2 minus 1/4 is simply 1/4. Minus, then here 3 minus 1/4 would be 11/4. All right, so we haven't done anything but simplify. We're still trying to take the derivative. We wanted to simplify it to a scenario where we have our nice derivative rule to follow. So in doing this, we get 1/4 x to the negative 3/4. Do you see why? We subtract 1 to that exponent, but bring out the old exponent to the front. Old exponent, new exponent is 1 less than the previous one. Then over here we have minus 11/4 x raised to the 7/4, where we subtracted 1 from this exponent, or 4/4. So this right here, this quantity would be is the derivative that we desire. Okay, let's look at one more example here in this video. What if we have x to the 7/3 plus 1 over x to the pi? How should we do this? Well, let's rewrite this as x to the 7/3 plus x to the negative pi and proceed. So we're going to take the 7/3, put it up front, subtract 1 from that to give us 4/3. This one, we're going to bring that negative pi to the front. And then x to the negative pi minus 1, where we subtracted 1. And that would be the final derivative. Thanks for watching.